Let's consider the topic of electrochemistry. Here you have chemical reactions in which electrons are transferred from one moiety to another. So say we have this following chemical reaction. So we have zinc solid and copper 2+ ions that are in solution. What can happen in this reaction is we form zinc 2+ ions and copper solid. So you can see in order for this reaction to occur, zinc has given 2 electrons to the copper ion. So zinc has lost 2 electrons, copper has gained the 2 electrons. So zinc has gone from the atom to the +2 ion, and copper has gone from +2 and gained 2 electrons to go to the copper atom. So this is a transfer of electrons during the reaction. So if we have a beaker of water and we have zinc solid here and copper 2+ ions in solution, then electrons can be transferred from the zinc to the copper, and we will form copper and zinc 2+ ions, which will dissolve in solution. Now, since electrons are transferred during this reaction, it would be nice if we could use those electrons to do something useful, like power your cell phone. So, in order to do that, we would need to separate the zinc and the copper and require the electrons to go through a wire. And while it's going through this wire, we can get it to power something that's useful to us. So we could break up this reaction, and we could have 2 beakers now. And say we have a zinc solid and we have copper solid. And we're going to connect these 2 solids by a wire. And we'll have zinc 2+ in solution and copper 2+ in solution. Now during this reaction, zinc is going to give up 2 electrons and go to zinc 2+. And these 2 electrons are going to flow through the wire and get to the copper solid, where copper can gain those 2 electrons, the copper 2+, can gain those 2 electrons from the copper solid electrode and plate out on the copper solid. So this is the same reaction, we just separated it into 2 halves, one half that loses the electrons and the other half that gains the electrons. And in order for the electrons to be transferred, now they have to flow through a wire, and we can get them to power something useful like your cell phone while they're flowing through the wire. So this is the concept behind a battery. Now one thing that you'll notice is that we have ions building up on the left side and ions being depleted on the right side. So we need to be able to balance the charge. And so what we do is we have what's called a salt bridge. And we will allow negative ions to flow from one side to another to balance the positive charge. So if I have copper 2+ in solution over here, I'm going to have some kind of negative ion. So say if I had chloride minus ions here, now I have zinc 2 plus building up here, but the pluses are being consumed here, and so the chlorine will flow through this salt bridge to the left beaker to balance the 2 plus charge that's forming with the zinc reaction. So this is a salt bridge, and it just allows us to have charge balance, so we don't have charge building up in the beakers, which would stop the reaction. Okay, we've broken the two reactions up, and these are called half reactions. So let's write the two half reactions. So we have zinc going to zinc 2 plus. This is one half reaction. This occurs in the left beaker. And then we have copper 2 plus going to copper solid. That happened in the right beaker. So these two reactions are called half reactions because they're one half of the total reaction. And the reaction that loses electrons is called the oxidation reaction. And the reaction that gains electrons is called the reduction reaction. So we have both an oxidation and a reduction. The oxidation is the species that loses electrons. Zinc is losing 2 electrons, and copper is gaining the 2 electrons. So to balance this equation, I would have to write the 2 electrons as a product for the oxidation reaction and the 2 electrons as a reactant in the reduction reaction, and now the charge is balanced on both sides of the reaction. So now we not only have to worry about the number of atoms that we balance, but we also have to balance the charge on both sides of the reaction.